Hey, what's up YouTube? Welcome back to my channel. I know it's been a while since I've made a video, but now that I have some time off from school, I thought I'd come back and finish the rest of Organic Chemistry 1. In today's video, I want to talk about substitution reactions. But before I jump into Sn1 Sn2 reactions, I want to briefly just talk about addition reactions and elimination reactions. Addition reactions are something that you should have already seen at this point. And elimination reaction is something we're going to cover at a later video. With addition reactions, overall you have, so you have A plus B to give you AB. So that's what addition reactions are, right? You have two different products to give you, two different compounds to give you one compound. Elimination reactions, you have AB, right? That's going to usually react with a base of some sort, right? To give you two separate products, so A plus B. So again, addition reactions, you should have covered this in your previous classes, previous lectures. Elimination reactions, this is something that I will cover at a later time, but the focus of today's videos are substitution reactions. So with substitution reactions, let's just say you have a compound right here with a leaving group, and you have some type of a nucleophile, and what's going to get, you're going to get your product, right? You'll have a brand new product, you have a nucleophile, and your leaving group. So what happened, right? We're substituting. So let me use a different color here. What's happening is that the nucleophile, pretty much it's taking place of that leaving group, and then the leaving group it leaves. So in terms of just A and B, right? So you have your A plus, let's use a different color actually. Let's say you have A, let's use yellow. So you have A plus B, right, to give you a completely new product, so C, and then your leaving group C and D. So this is just the overall mechanism of a substitution reactions. Of course, there are two types. We're going to get into that. But the overall reaction, you have A plus B to give you C and D. Now, before we go into the details of Sn1 Sn2 reactions, there are some definitions that you'll want to be familiar with. First, electrophile. An electrophile is an electron pair acceptor. So if you look at the name, right, electro referring to electrons, and then phile referring to love, right, to love something. So electrophile is an electron pair acceptor. A nucleophile, on the other hand, right, is something that loves the nucleus. In other words, a nucleophile is something that is an electron pair donor. So a nucleophile, it's rich, it's rich in electrons, and it's going to attack an electrophile. So the way you want to, if you want to memorize this, think about a nucleophile, you think about a nuke, so you think about attacking, right? So a nucleophile, it's going to attack an electrophile. A leaving group is a substituent that will leave from an electrophile. That will leave from an electrophile. And then finally, we have a concerted mechanism. A concerted mechanism is one where you have something that attacks and then something that will leave simultaneously. Now let's go into the details of Sn1 Sn2 reaction. So the big thing that you want to know about Sn2 reaction is that even though the Sn1 Sn2 reaction, even the names are kind of misleading, but for Sn1 it is a two-step mechanism. So again, the Sn1 Sn2, the numbers 1 and 2, they refer to the reaction rates, but that's something we're not really concerned about. We just want to know what happens in the reaction and what are my end results, what my end product is going to look like. So Sn1, it's a two-step reaction. So let's just say I have some compound, right, with some leaving group, and then I have a nucleus. So the very first step in a Sn1 reaction is that your leaving group will leave on its own, right? It'll leave on its own to give you what we call a carbocation intermediate. A carbocation intermediate. And then you have your leaving group by itself. So the very first step in a SN1 is the formation of your carbocation. The second step, right, this is where you'll have a nucleus. So you have your carbocation, and then a nucleophile will come. A nucleophile will come and attack, giving you your end product, which will look something like this, plus your leaving group. And then an Sn2 reaction, it's different in that it's a one-step reaction. It's what we call a concerted, like I just mentioned earlier. It's a concerted mechanism. So in a Sn2 reaction, let's just say you have some compound with some leaving group, and then you have some nucleophile. So in a Sn2 reaction, so it's a concerted mechanism, it's a one-step mechanism. Your nucleophile will attack, and at the same time your leaving group will leave, so giving you your end product. So it will look something like this, a nucleophile, and then your leaving group. So in the next video, I'm going to go over the different examples, and we're going to work through different examples. But overall, the biggest difference that you want to learn about Sn1 Sn2 reaction is that Sn1, it's a two-step mechanism, and you're going to have a formation of what we call a carbocation intermediate. And Sn2, it's a concerted mechanism, right, where you have your nucleophile that's attacking and your leaving group that's leaving at the same time. So that's it for this video. Oh, one thing that I want to mention is your nucleophile. It's going to do what we call a backside. So that's where I drew the arrow. It's going to do a backside attack. So attack from the backside of the molecule, and at the same time your leaving group will leave. So this is what's called a concerted mechanism. So in the next video, we're going to talk about more examples and work through them.